Alright, the shape. Right, the shape is determined by this constant here, that constant there. Since it is positive, means that the value of A is positive. Therefore, when I draw my two curves, one will be in the first quadrant, the other one will be in the second quadrant. So before you draw the graph, you need to know how it looks like first. Okay? Then the equations of the asymptotes, equations of asymptotes, please, they are equations. Okay? So the vertical asymptote, since this is a grade 10 function, it's always x equal to 0. The horizontal asymptote is going to be given by y equal to 2. Okay? Then we need to determine the x-intercept. To get that, we substitute y equal to 0. So where there is y, we put 0. Get 1 over x plus 2. You take the positive 2 to the left. Get minus 2 equal to 1 over x. Then here you can just swap the x and the minus 2. So x will be minus a half. Right? Then the y-intercept, since this is a grade 10 function, it doesn't exist. But let's prove that it doesn't exist, or there is no y-intercept. If I put x equal to 0 there, okay, because of this, because of that, what is 1 over 0? Undefined. What this means is that x is undefined. Therefore, there is no what? Y-intercept. That's the reason why the grade 10 function has got a y-axis which is an asymptote. Okay, because x is undefined there. Right, now I can sketch. But I also want you to be aware, we can go further and determine the equations of the axes of symmetry. Okay, the equations of axes of symmetry. So I'm going to move on to the next page. Equations. I'm going to draw these equations. They are graphs. Equations of axes of symmetry. Okay, equations of axes of symmetry. Now, since this is a grade 10 function, the equations are y equal to x plus q. Okay, the other one is y equal to minus x plus q. Therefore, the one with the positive gradient is going to be equal to, remember this 2 here, that's our q. So it will be y equal to x plus 2. The second one will be minus x plus 2. Are you following there? Are you following? Yeah, so I'm going to sketch those lines of symmetry as well. Right? So let me move on to a page where I will sketch. In grade 10, P is 0. That's why you don't see any P values. Because there is no horizontal asymptote. The P is 0 in grade 10. Alright, so let me move on to the page where I'll sketch now. Now, if I want to sketch, first thing, draw my x-axis, sorry, my y-axis first. Let me check my intercept, so they'll give me an idea. So I've got x equal to minus a half, my asymptote y equal to 2. Okay, so I can just put my x-axis there. Then, first thing, you draw your asymptotes. The y-axis is an asymptote. Its equation is x equal to 0. Right? Then, we have a horizontal asymptote which is y equal to 2. So if I calibrate this as 1 and that one as 2, maybe I can put -1, -2, and I can have 1 here, then 2. You must use a ruler. I don't have a ruler, right? So, first, the horizontal asymptote, and its equation is y equal to 2. Once you draw the horizontal asymptote, that horizontal asymptote will now behave like it's your new x-axis. Okay? Right? So your first quadrant is now between the y-axis and the horizontal asymptote. Second quadrant is now between the y-axis and the horizontal asymptote. Third quadrant, the horizontal asymptote, y-axis. Fourth quadrant, y-axis, horizontal asymptote. Are you following that? So after drawing the asymptotes, you now plot the points where the intercepts are. We don't have an x-intercept, but we have got y-intercept. So sorry, we have got an x-intercept, which is an x equal to -1, but there's no y-intercept. So if I go to x equal to -1, it will be somewhere there, right? That's where it is. Since I have to sketch my graph in the first quadrant and the third quadrant, means when I draw it here, the first quadrant, right? Third quadrant, like that. Okay? Are you following that? So yesterday, if you drew the graph, you're supposed to have got that, right? Then I'm going to add the axes of symmetry. Now in grade 10, the axes of symmetry were not very important, but in this grade now, they are very important for you to know because they can be tested. Okay, you might see them in your test next week in your final examination. So I have to talk about them, right? Now, it's very important for you to know that the asymptotes and the axes of symmetry, they intersect at a common point. Okay? And that common point in this case here, our y-axis is an asymptote. The line y equal to 2 is an asymptote. The two intersect here, which means my axis of symmetry will pass through this point as well. I'm going to repeat that because it's a very important concept. The asymptotes and the axis of symmetry, they intersect at a common point. Right? So if I want to know where the lines of symmetry are going to pass through on the y-axis, it is this point. Right? Y is 2. If you check here, what's the y-intercept there? What's the y-intercept there? The 2. Okay? So, all we have to do is determine the x-intercept of the line of symmetry. So, because the linear function is the simplest of the four functions. If you substitute y equal to 0 in the first one, you get x equal to -2. If you substitute y equal to 0 in the second one, you get x equal to +2. So, x equal to -2, this point here, is going to be my x-intercept for the line of symmetry with a positive gradient. So when I draw it, it goes that way. Unfortunately, I don't have, okay, the second one, I don't have a ruler, so I'm going to use a solid line. But when you draw yourself, you must not use a solid line, okay? Then, for the second one, if I put y equal to 0 here, I'll get x equal to 2, which is this point. So the one with the positive gradient goes that way. The one with the negative, the one with the positive gradient goes this way. The one with the negative gradient goes that way. So let me just draw. Okay. Let me choose that line. Right. So I'll start with the one with the positive gradient. It will look like this. Stop. Okay. Okay, so that's my line of symmetry with a positive gradient. Right? The one with a negative gradient, I can draw it. Yeah, I'll move it up a little bit. So let me move it a little bit to up. That's better now. Okay? So we have our two lines of symmetry. This is y equal to minus x plus 2. And this one here is y equal to x plus 2. Okay? This is very important. The three intersect at a point, sorry, the four of them rather, they intersect at that point. Always. The lines of symmetry or axes of symmetry and the asymptotes intersect at a common point. Okay? Now, that is a very important concept later when you are going to try and find the equation of the axis of symmetry. That concept will help you later on. So this is a grade 10 function. Okay? Let's talk about the domain. Is there anybody else got any question? Yes?
So the general equation for the line symmetry is x plus q.
In grade 10. The one with the positive gradient. Remember, the function that I just drew here is a grade 10 function. I just wanted to do a recap of grade 10. Remember that. So the domain here, right, x can never be 0 because y-x is an asymptote. So the domain will be x is an element of real numbers, but x is not equal to 0. The range, y cannot be equal to the value along the horizontal asymptote. Therefore, if y is an element of real numbers, but y is not equal to 2. Okay, so that's your domain, that's your range. I prefer that you use this notation because it's the easiest than to use brackets and inequality. Usually for the hyperbola, it's a little bit more complex if you use other notation. This is a little bit easier. Okay, any question? Now, before I move on, I just want to let you know that in grade 10, this is how it would look like. In grade 11 now, the asymptote will move to the left or to the right. That's where the p-value comes in now. So when the asymptote moves, the whole graph moves, including the point of intersection, it will also move. So if I were to move this, the asymptote by, say, 2 units to the left, it means the point of intersection also moves by 2 units to the left. If I move the asymptote by 1 unit to the right, the point of intersection also moves by 1 point to the right. When I say point of intersection, I'm referring to the point where the asymptotes and the axis of symmetry intersect. Yes?
You said those lines of axis of symmetry doesn't be solid. What does that mean?
You must use dashes like this, like how I drew the horizontal asymptote. Yeah. Unfortunately, my software doesn't have dashes, so I use a solid line. Okay. Then, but we have another question. Ronnie, can you put that away, please? And you too. Put it in your bag. Right. So now I have to sketch the next one now. I'm going to follow the same procedure to sketch this. So what f of x equal to 2 over x plus 1 plus 3. So f of x equal to 2 over x plus 1 plus 3. Now this is a grade 10 function. sorry, 11 function. This is a grade 11 function because of this. There is horizontal shift. Okay? So first, let's determine the shape. That value there is positive. So A is positive. Therefore, when I scale it, it will be in the first quadrant, second quadrant, third quadrant. Okay? Then, equations of asymptotes. Okay, let's start with the vertical asymptote. The vertical asymptote, based on how I taught you with the general equation, it's x equal to minus p. Okay? It's x equal to minus p, but I just want to take you back, right? X plus 1 will be equal to x plus p. The way am I getting this? I'm getting it from the general equation. The general equation is y equal to a over x plus p plus q. So I'm equating here this denominator and that denominator so that I can get the value of p, right? So these two cancel out, so p is going to be 1. But the general equation for the horizontal asymptote is x equal to minus what? Minus p. So this p is equal to 1, therefore my equation will be x equal to minus 1. You can be tempted, yes. You can be tempted to write x equal to 1 as the equation of your asymptotes when it's x equal to minus 1. So my suggestion is determine the value of p. Memorize this.
So you equate the
Yes, memorize this as well. Don't rush to just write the answer from your head. You can make a silly mistake there. The horizontal asymptote, it's very easy. It's y equal to q, which in this case is y equal to 3. That's straightforward. The equation of the horizontal asymptote is very straightforward. The one for the vertical, that's the one you need to be very careful when you are trying to determine it. Okay, then I've got that. Let's move on to get the y-intercept, x-intercept. Okay, so x-intercept. We get this when f of x is 0. Remember, f of x is y. So 0 will be equal to, we have a 2 there, so 2 over x plus 1 plus 3. Now, if you want to find the y-intercept after substituting y equal to 0, please don't complicate things. Take this positive 3 to the left, you get minus 3 equal to 2 over x plus 1. Then the denominator there is 1. You cross multiply. So you end up getting minus 3 times x, which is minus 3x, minus 3 times positive 1, minus 3 equal to 2. Then you solve this. It becomes minus 3x equal to 5. Divide both sides by minus 3, you get x equal to minus 5 over 3. So that's the x-intercept. The y-intercept, now it exists. Okay, you substitute x equal to 0. In grade 10, there was no y-intercept because the y-axis was an asymptote. In grade 11, the y-intercept will exist. So, we put f0 is equal to 2 over 0 plus 1 plus 3. To simplify this, don't make it complicated. Remember, division starts first from your knowledge of BODMAS. So, you need to simplify this before you start including that positive 3. So that will be 2 over 1 plus 3, which is 2 plus 3. and that will give you 5. So the y-intercept is going to be 5. Okay? Then, equations of axes of symmetry. We need to know our equations of axes of symmetry. Equations of axes of symmetry. Sorry. The first equation, one with the positive gradient, is y equal to x plus p plus q. Okay? But our equation is given as f of x equal to 2 over x plus 1 plus 3. Okay? So we know, or you know by now, that this plus 1, that's the p value. P is 1. That plus 3, that's the value of q. So the equation is going to become y equal to x plus 1 plus 3, which will give you y equal to x plus 4. Alright? The one with a negative gradient is y equal to minus x plus p plus q. Okay? So this will give me minus x plus 1 plus 3. If I simplify that, I'll end up getting minus x minus 1 plus 3, and we get minus x plus 2. So those are my two lines of symmetry. Okay? Now I'm going to sketch them as well. And I sketch the graph. Is there anybody who has got any question? Okay. Don't have a question, then let's take one. So now I'm going to sketch. And let me check my intercepts. I've got 4 positive 4 there, positive 5. Okay. So, I've got positive 2 as well. Right. So let me draw it like that. Okay. So let me calculate that. So my x, if I make this one 1, that's 2. Minus 1, minus 2. We make this one minus 2, that one could be minus 4. So this will be positive 2, positive 4, positive 6. Okay, so let's start with my asymptote. I've got x equal to minus 1, which passes through this point. So it will be somewhere like that. It will be that one there. Then I have a horizontal asymptote at y equal to 3. So y equal to 3 is somewhere here. So that's y equal to 3. And remember, this is x equal to minus 1. Then I need to identify my y-intercept. I have y equal to 5 as an asymptote, so as a y-intercept, y equal to 5 there. Then I've got x equal to minus 5 over 3. Minus 5 over 3. This is and up, so it will be somewhere there. Okay? I'm just approximating. Right? I know my shape. It's supposed to be the first quadrant and the third quadrant. So now I can draw. If If I draw it, it should look like this. Okay? Then in the third quadrant, it should be something like that. Okay, so that's the graph, right? Then I need to add the axis of symmetry to it. The good thing is, I know that my axis of symmetry, they pass through this point. Okay? And the equations of those axes of symmetry, the first one is y equal to x plus 4. So I just need to find its x-intercept. The y-intercept is this. So I can plot that point, right? So it means it will pass through this point. Okay? It will pass through that point. Obviously, it will pass through this point. So this, sorry, there is an x-intercept along the x-axis. Don't behave like you are a bot. Don't behave like you don't fall for long. Right? So if I substitute y equal to 0, x is going to be negative 4. So negative 4. Well, just allow me to extend a little bit. Allow me to extend this point here. Okay? If I extend it like that, maybe I can have minus 3 there, then minus 4. Okay? So let me draw it. So when I draw it, right, please, my graph may not be very accurate because of scale issues, but it should look something like this. Okay? Okay, so that's the one with the positive gradient. It has got a y-intercept here, but it passes through the point of intersection with the asymptotes. Right? Then the one with the negative gradient, it has got a y-intercept, which is at y equal to 2. So I can go to my graph, y equal to 2 is going to be here. This is y equal to 2. So let me indicate that point. Y equal to 2 is here. Obviously, it will pass through this point. Okay? So I need to identify what is the x-intercept there. The x-intercept, if I put y equal to 0 here, I'll get x equal to 2. So on the positive axis outside, I don't need to make any adjustments. Okay? Then when I draw it, well, it should be something like this. It's not perfect. Okay, I'm going to make sure that it passes through the x-intercept. I need to adjust it, move it down a little bit. Okay, perfection will not be able to. Please bear with me, there is a scale issue. Okay, so this point here is supposed to be there at x equal to 2. And it's supposed to be y equal to 2. And this is supposed to be at the point of intersection. Okay, now because of my scale, that's why it's not coming out right here. Right, but my equations for the one with the positive gradient, y equal to x plus 4, the negative gradient, y equal to minus x plus 2. Okay, so this is what you're supposed to have.
So the values were the same.
What values?
For the x and y.
No.
The two of the two were in the formula.
You said the values are the same. What do you mean?
Like if you're gonna get y is equal to x plus 4, that's gonna be the y intercept, right?
Yeah, this one.
Yeah. So then the value is going to be 4 for the x intercept.
Then you can say, okay, I don't want to interpret it that way. But it looks like the x and y intercept, they are opposites in terms of signs. So when the x-intercept, so when the y-intercept is positive 4, its y-intercept is negative 4. When the y-intercept is positive 2, in this case here, then it will be, in fact, both of them are going to be positive. You see that now. So the one with the positive gradient. So in the case of the one with the negative gradient, both the x and y intercepts are positive too. Okay, but in a nutshell, you need to know that the x, the asymptotes and the lines of symmetry, they intersect at a common point. And the coordinates at this point here are going to be x equal to -1 and y equal to 3. Sometimes you can get a question in this grade asking you to determine the value of the y-intercept of a line of symmetry. Let's say if the line of symmetry has a positive gradient and its equation is y equal to c, they may ask you to determine that c. In that case, you have two ways of getting the answer. Either you can substitute the coordinate at the point of intersection, okay, or you can go back to the basics and use this equation, okay? If it's a positive gradient, if it's a negative gradient, you can use that equation. Okay, later when I do a question, you will probably understand. Okay, so I've covered a lot of things here that you are expected to know at grade 11 level. Then we need the domain.
So how many marks for speaking was that?
Usually 3 marks.
3?
Yeah. Right, the domain, most of the time is 3. The domain will be x is an element of real numbers, but x is not equal to the value at the asymptote, which will be equal to -1. The range is y is an element of real numbers, but y is not equal to the value at the horizontal asymptote, which will be positive. Are you following? Is there anybody who has got any question?